Hello everyone, I'm Vinay Nimawat with my teammate Vishnu Acharya and Ruben Cardoza, and we are here to present our project Speed Dating. Actually, what are the attributes influencing the selection of a romantic partner? So let's start with the introduction. Our project aim was to study the dating behavior using data from a speed dating experiment. Random matching of subjects is generated and random variations are created among the partners, and this will benefit every single individual who will seek to give a shot to the online dating, as they can be aware based on their characteristic that how they are going to end up. Next is the purpose of project. Mainly we have three purposes of the project. The first one was what attributes are the key for the decision whether the match will see his or a partner again. Then secondly, building a predictive model based on factors that will give the user a clear vision of what to expect from their partners. And the last is it will help the aspiring users whether or not to give online dating a shot. Now moving on to data preparation part. So we performed all the steps of the data preparation starting from data access till data reduction. And here you can see a snapshot of all the process. So like we have source from Kaggle, consolidation we have done in Excel and R, cleaning we have around 70% of the missing values which we handled properly. We did imputation using mean and median, we did transformation and reduction. So let's go in detail of each and everything. First one is data access and consolidation. This data is taken from an online data repository named as Kaggle.com. This repository is having a lot of data, and we got a really good variety of data because actually there were 4 Excel files in which there were around 16 different waves of data which were taken into consideration. Then we divided the data into 2 different files, one file with the categorical data and one file with the numeric data. And with this did separation using the check data quality function of R. Next was data cleaning. So as we know that there are a lot of missing values, there are a lot of redundant values, everything was handled properly. And for all the categorical interval variables, we replaced the values by mode and mean respectively. There were some outliers as well for the variables like age, stated preference, etc. And we detected them and we cleaned them. Then there were some redundant values which were removed using Excel. Then there were few variables which have almost more than 70% missing values. So we decided to remove that variable out of consideration. Next was the data imputation part. So according to our file, we have only one missing ID in our dataset. Hence we assign the missing ID IID to this IID. And we followed this logic that if there is 10 PID missing and no partner missing, the partner value will lead us within the wave to this missing PID. We also performed imputation on zip codes because there are a lot of zip codes which are 0 and this should be changed to NS. Next was the data transformation and reduction. We did a square root transformation for 2 of the variables, internal correlation and order. And after doing the square root transformation, we saw that normality is somewhat skewed. We changed the scale of the variable stated preference from 1 to 100 to 1 to 10 using the rescale function in R, which makes it pretty simple to interpret. We also performed PCA analysis on our data to reduce the columns, and we reduced our columns to 42 from 195. Next is the model building part, which will be explained by my teammate Ruben Cardoza. Thank you.
Thank you, Vinay. Hello everyone, my name is Ruben Cardoza and I will be handling the next part of the presentation. Let us first begin with the model building part. To select a viable modeling technique, we did some descriptive analysis. And during our descriptive analysis, we found that most men were from the field of business, economics and finance, while most women were from the field of education and academia. We also discovered that the field and careers variables had several uncoded values. Hence, in order to reduce our scope and make our project more accurate, we decided to drop all these uncoded values. After doing the descriptive analysis, we found that there were 8 important variables, of which like was the most important, while intelligence was the least important variable. Since our dependent variable is binary, we chose logistic regression and decision tree as our modeling techniques. Now with logistic regression, we can interpret more easily regarding the variable importance for predicting the target. No linear variable is required between dependent and independent variable. Interactions of power terms can be added. Normality of dependent variable is not necessary. Homogeneity of variance assumption is also not needed. The second technique that we chose was decision tree. This was chosen because it is very easy to interpret and visualize the splits. For instance, in our model, the variable decision shows different criteria for every split of independent variables. Also, the decision tree implicitly performs variable screening of feature selection. Nonlinear relationships between parameters do not affect the tree performance. Less effort is required in building models, and most importantly, it is easy to interpret and explain to executives. Now let's move on to the model assumptions. With logistic regression, since our target is binary, logistic regression is the best model as it requires the dependent variable to be binary, and hence we have coded the target accordingly. Logistic regression is sensitive to overfitting and underfitting. Hence, we have only included meaningful variables, and these variables were determined by using the stepwise method of logistic regression. With decision tree, the model, we use discrete predictors that help to explain the tree, hence continuous variables are converted to categorical variables. Secondly, decision trees do not need any assumption in linearity of the data, so we can use them when the parameters are not linearly related. Pruning is an important factor without which the tree may overfit and the training data, making it a poor model. Hence, the tree uses a greedy algorithm that will stop at a reasonable number of steps. Now moving on to data splitting and subsampling. We have taken 70% of our data as training and 30% of our data as validation. Now we have taken this partition because we have a very large data set, and after filtering and cleaning we came down to 8,379 rows. We also performed subsampling to reduce the data. The next part of our presentation will be handled by my colleague Vishnu Acharya. Thank you.
Thank you, Ruben, for your time, and now I'll explain the results and assessment of our project. So we built two models. Logistic regression, as our variable was categorical, so we have to go for logistic regression. And also we built decision tree model to see, find which model is going to be a good fit with our comparison. So to start with logistic regression. So for logistic regression, we built two models, Python for both males and females for the data, and to find the best decision by the partner, whether they want to see their partner again or not. So the F statistics of the model was found to be 169.5, which is an optimal fit for the goodness of a fit. And the R square for female model is better than the other model containing the males. Moving on to the next. The decision tree. The decision tree is again serving the same purpose. The main advantage of the decision tree is that it doesn't limit to one cause and effect relationship and describe the context in multiple variable influence. That is, like a decision tree splits at different criteria at each segment at the importance of the variable at different segment. It is not like splitting the entire data into on a same thing, just a single variable or single conclusion. It is splitting at different nodes, so that gives a more visualization of and more accuracy of the data. So this is the decision tree model that is built by R. So that model finds the race to be the most important variable. The race is categorized from 1 to 7 in our data. So those are like Black, American, Native American, Caucasian, and Latino. All these categories were assigned to the race. So those who come under 3 and come under greater than 3, those were split at 3. So if we'll consider the left side of the tree, it can be seen that the next important variable found is to be age, and that is again split at 31. Like people who are either greater than 31 or less than 31 of age, those are split, and more like the less than 31 are likely to be more preferred. And after that, those people who are having less than 31 of age are again split by their religion. So the religion is again a categorical variable, so that was number from 1 to 10. So that with less than 5 are split and greater than 5 are split, and there also comes a race. And similarly, the right side, if you can see, the race is split into again same race and then age and then int core, like this. So this is what explains what I earlier said. As I said, the race was ranked categorized from 1 through 7 for Black, European, Caucasian American, Latino, Asian, Native American, and others. And the split is made at 3, and after that age, which was done at 31, and then religion. So the selection of the final model. Based on our assessing and results, we found the decision tree was very good model for our goodness of fit, because we focus more on the model accuracy to predict the partner distance, and also we have given importance to practical significance of the predictor variables in order to assess the performance. Considering all the factors, we found the decision tree to be very good, as I explained earlier, because of the split. And it doesn't consider there are not very limitations of finding a decision tree, because in regression there are a lot of assumptions which is covered by the decision tree. It doesn't bother about the assumptions. So original versus final product. The original vision of the project was to find the decision of a partner after their first meet, and in the final, yeah, it was the same, but and by comparing both the models of our result, like the decision tree and the logistic regression, and also it included the descriptive statistics and the interesting findings of the data. Sorry. So as you can see, the descriptive statistics, the career partition of both males and females in this data shows the both maximum of the males come from banking, business, CEO, or administration, while the females come from academic or research. So both have a different kind of interest. And matches by the waves. This chart shows how many waves is the optimal to find a match. So as you can see, the people, there is not a certain linearity in this, but it is seen that people sending 4 waves are getting a good like, and after 9 it is, you can see from 9 till 15 the data is they are more likely to find a good match. So the optimal waves that should be sent by the partner would be a 9 to 15, and it is also there are some outliers in our data, people sending 21 waves, more than 21 waves are likely to get more matches. Interesting findings. So this graph shows the probability of finding a match versus the difference in ages. As you can see, the difference in ages increases, there is definitely the probability of finding the match reduces, because most partners prefer the difference of age to be less. But if you can see, from 0 to 5 there is a difference of 0 to 5 in ages, that is a good, they don't bother about that. And as from 5 to 10 there is a decrease in the probability, and after 10 and 15 no one wants to see their partner again. This is one of the cool findings again. This is the match versus decision table, and this shows, because there were as you can see in the red, there are a lot of partners who were not even matched, but still they wanted to date their others, their partners who were not even a match. So maybe because of their interest, or maybe their career field of interest, or some other attributes matched, which didn't bother the decision factor. So lesson learned from this entire project. It was very good experience again, because R and Python was totally new to us, and we have to do the entire assessment with R and Python, starting from the statistics till building the models. And team playing was most important, because we were using a lot of meetings, and we are distributing the tasks equally so that it will be effective, and it was leadership and team playing was developed among us. And paperwork and documentation were those are too important, and we learned how to document well for a professional perspective. And the most of the time taken was in data preparation, and we explored R and Python more while for our data preparation, and selection of the model was as important. Thank you very much for your time, and please, if you have any question, you can always reach out to any of us. This is our email IDs. Thank you.